These two are collectively, these two are called as members of a class, right? Members of a class. Okay. So how do we define the variables of this particular class? How do you define the variables of this particular class? Sorry. So once a class is defined, we have to create objects of that particular class. And we will do that with the use of a new operator, by using new operator. Okay. By using new operator, we will create objects of a particular class that we have defined. Okay. So what does this new do? It allocates memory. It allocates memory for the object, okay, that we are creating, and returns a reference to that particular object, which we can store it in any variable of the particular class. Okay, any variable of that particular class. So we have seen in yesterday's class, we have seen how a particular reference looks, right? And okay, let's do this way. Okay, so this is how you define your class keyword, and then name of the class. Okay, identifier. So curly braces are class brackets define your whatever the code that you write, right? That contains your this one. What is your class numbers? Okay, it can be instance variables, and it can be your methods. Okay, instance variables. The syntax, you know how to define instance variables. Okay, it starts with access specifier. Okay, and then your type, data type of instance variable. It can be primitive data type, or it can be your complex data type as well. Okay, so instance variable ID. Okay, and methods also, you have access specifier, and then return type, okay, and then method ID, method ID, and then it open and close parenthesis, and then flag brackets or curly braces. Okay, here you can specify your parameter list. Okay, each parameter list is nothing but your type and ID. Okay, type and ID. So I mean pair of type and ID. Okay, within this flag brackets or curly braces, you can mention your method action. Okay, what that particular method does. Okay. So next we move on to this. Okay. Okay, let us take one simple example which covers everything, all these things. Okay. Let us take okay, let us define one particular two-dimensional array. Okay. Okay. Now, so what we will do here is we will define two-dimensional array here, and then we will define method. We will mention. Okay. So we will try to print these values using different methods. Okay. Don't get confused with this variable and this variable. Okay. Let us try this one only. Yeah, I'll come to all of your points. Okay. So I'm just trying to explain this. We'll come to all your points. So constructor overloading and other things. Okay. Let us make this static. We'll see how static works. Okay. Briefly, to tell briefly, static, right? Static, anything which is defined as static, anything, it can be instance variable or it can be a method. Okay. So what we have seen in our previous session, right? So here, if you see here, okay, if you see here, all these methods, they're all normal methods, right? These are all normal methods. These are all normal methods, right? All these things are normal methods. Okay. These are all normal methods. So what does that mean? Normal method means, so whenever you within static, public static void main, right? If you want to use any of these methods, or if you want to call, not only within methods, if you want to call any methods on a particular, or if you want to access any members of that particular class, right? If those the instance variables and methods are normal, you have to create an object. Okay, you have to create an object, and then through that object only you can access those methods or member variables if the access specifiers are proper. Okay, that is how we have done here. Okay, mo.test. So we have seen how. Yes, correct you. So only objects can access through objects only we can access the members. We have seen how a dot operator works, right? We have seen dot operator. We have seen dot operator, right? So using dot operator only we can access the members of a class. That too depends on your access specifiers. Based on your access specifier. Okay. So what difference does static make? Okay, this is instance variable. This particular, here, if you come here, and if you specify some variables here, right, they are all instance variables. Okay, so let me explain that particular part real quick. Okay, so if I specify static here, this becomes your, you can access this particular method without your objects. Okay, this becomes a static method, and this can be accessed by within this main public static void main class without creating objects of this particular class. Okay, this is static here. That means this method is a static method. So you can access this method. Okay, you can access this method without creating objects of this class. Yeah, here is telling correct. Without creating the objects of this particular class. Okay, let us try that this one. So what I'm trying to explain here is, so let us remove this particular static part. Okay, and then in this case, when the method is not static, how we have to access this particular method? We have to create an object. Okay, then you can call that particular method. Okay, so what is happening here? We are not assigning this particular reference that is written by new operator to any of the variables. We are just creating a new object, and then we are calling this particular method. Okay, but still, if you want to create an object, test t is equal to new test. Okay, you can do this way also. Okay, you can do this way also. But when you make static, okay, when you make static, you need not have to create an object to access a particular static method. Okay, now this became static. This method becomes static, right? So you need not have to create an object. You can access static methods by using this particular syntax. Just mention class name dot static method name as the parameters. Okay, and pass the parameters. This is how you call. This is the class name. Class name is nothing but your name of the class. Class name is nothing but your class name where that particular static method is defined. A static method name is our static method name here. Okay, so what are the parameters that it takes, that we have to specify. Okay. So how we do that? Okay, it has printed. Okay. So what are we doing here? We are trying to pass two-dimensional array here. We have defined the two-dimensional array, and then we have passed this two-dimensional array here. Okay. So we have defined a separate method to print these array elements. Okay, and we have passed the two-dimensional array to as argument to that static method. So why I took the static method is I did not want to create a new object to call that one. I just wanted to create or call this static method directly on class. Okay, directly on class name. That's why I made it as static. Okay, just simple. So we will see what are the characteristics of static instance variables, static methods. Okay, so yeah, Kavita, correct. So this is one thing. Okay, so apart from this, if you strike off this particular static, this is your return type, this is your method name, and these are your parameters. Okay, next move on to. So if you have anything related to classes and this, okay, let me recap this. Just defining a class, we have class by default class ID, class identifier. Okay, class identifier. This is our access specifier. I don't mention here. And then methods we will write as return type, syntax, method identifier, and parameters. Okay, open and close brackets are your curly braces. Okay, and so next we will go to overloading. Okay, overloading is like as we discussed yesterday, it is giving same. We have seen couple of examples in our English language examples, right? We have seen a couple of words that is your rows, your right, and gray, and all those things we have seen, right? Right is can be the same word, but based on the context, it takes a different meaning. Okay, while driving, if you say take right turn, that means you are specifying the direction, how to take the direction, right? Which way to take turn. But when we are speaking and if someone says something correct, we will say, yeah, he is right. Okay, based on the context, the meaning will be derived. Similar to that one. So what exactly is happening? For the same word, we are giving different meaning. Okay, same word. Okay, same word, but based on the context of using, how we are using that particular word in different context, that makes the difference. Okay, similarly, that is called overloading. Okay, overloading, meaning overloading. I mean, word is overloaded with different meanings. Okay, and the meaning is derived based on the context in which you are using that particular word. Similar to that one. So method overloading. Okay, similar to that one, we can, in method overloading, we will use the same word or same method identifier with different parameters. different parameter list. Okay, and for any method we will have return type. Return type will not have any effect on these methods. Okay, method I mean while resolving the overloaded methods. Okay, so the main thing that we need to remember when overloading a method is, the main thing we need to remember is parameter list. Okay, the main thing that we need to remember is parameter list. Parameter list should differ. Okay, so that here double, here double integer, and here the number of parameters. Okay, so what is happening is while Java resolves the overloaded method, it takes the type and number of parameters. That means whatever the arguments, while calling this particular method, whatever the arguments that are passed, right, those arguments, okay, number of arguments and the types are matched with the type and the number of arguments of particular parameters of a method. Okay. Okay, so it is matched and the corresponding method will be invoked. For example, here, if I don't have this yesterday, as we saw yesterday, if I don't have integer and if I pass, if say assume that I don't have this integer method which takes integer. If I pass integer here, this method will be called because of automatic type conversion. Automatic type conversions. Okay, so that is what we have seen here. Okay, so initially we did not have this particular test method. So when we call test method with integer, we were able to execute this method because this method was not there. Okay, this method was not there. So the main thing to remember about automatic conversion is important thing is automatic type conversion happens only when the exact method or exact match is not found. Okay, if there is an exact match, then you will not I mean that particular method will not be used. I mean exact method will be used. Okay, exact method will be used. In this case, what exactly is happening here? So initially we did not have if we don't have this particular method, then we call with integers. Okay, when we call the method with integers, this method will be called because automatic type conversion happens and these two things get converted into double, and then the double method will be called, 2 parameters. Okay, so this happens only when automatic type conversion happens only when there is no exact match. Okay, but if we uncomment this particular part, okay, okay, and try to call with this method with the integer parameters, then this particular method will be called. Okay, this is your operator overloading, I mean method overloading. And then we'll move on to similar to how we did method overloading. Similar to that one, we can have constructors also overloaded. Okay, we can define constructors, or we can have overloaded constructors. Give me a second. So overloaded constructors. We can also overload constructors. So what is the main thing that we need to remember when overloading? The parameter list should be different, right? So here we have box constructor, which initializes the box object with -1, all the parameters, right? And then we have another box constructor, which initializes box object with specified dimensions. So to specify a cube, we mention all this as same, okay, one particular dimension, and then assign all the dimension to the same whatever the dimension is specified, length or whatever it is, okay. And then we are calculating it here, and here we are using the same name. Loading is nothing but we are using the same name but different operations, right? Here we are initializing the object with default values with some specified values, and we are passing only one dimension and assigning the dimension to all the three dimensions, all the three parameters in terms of variables to make it a cube. Okay, so here no parameters, three parameters, and one parameter. So number of parameters and type are at least the number of parameters are changing here, right? Number of parameters are changing here. So we are using the same name but different parameters. And here, so if you see here, different actions, we are taking different actions here. So we are assigning -1 here. We are assigning whatever the values that we have passed here, and we are assigning one particular value to all the instance variables. Okay, so based on what we want to do, or what is the parameter being passed to this particular constructor, the respective constructor will be called and corresponding object will be created, right? So here we are creating one particular object with default constructor. Okay, with default constructor. With default constructor, right? So in this case, all the values will be -1. Okay, so when we try to print this, the values will be -1. So here we are passing one, because one parameter, so it creates an object cube. Okay, that's what we are named here. And here we are passing three parameters. So correspondingly, a constructor with three parameters will be constructor with three parameters will be called, right? And correspondingly, the object will be created. So you can see whatever how the objects are created. So instance variable values I have printed here. So whenever you try to print these values, we have a toString method defined, right? toString method. toString method we have defined. So that is called whenever you try to append or use concatenation operator with the string. Okay. So the different dimensions of particular object I'm trying to print in the toString method. Okay. And then they are getting printed here. This is how I am trying to print in toString method here. Okay. So to box dimensions, height, width, and depth I'm printing. The same thing is getting printed here for respective objects. Okay. So this is how constructor overloading is done. So any doubts with respect to these things? Any doubts you have? Anyone has any doubts regarding this topic? Overloading, method overloading, object overloading, or constructor overloading? Okay, so let's move on to this particular object parameters. And yeah, we have seen one particular thing, right? So that is overloading. So how polymorphism is nothing but we use the same interface, but we'll provide different implementations, right? So one way of implementing polymorphism in Java is your method overloading. There is one more thing, which is method overriding. We will see when get to the inheritance part. Okay, and we will discuss about other part like what is overriding. Okay, so right now we will concentrate on method overloading and object. I mean, just the overloading. It can be method overloading or constructor overloading. Okay. So apart from that, we can add till now we were seeing like primitive types being passed as parameters to methods. Okay, primitive types being passed as parameters to methods like this box. This is a 10 is the primitive type, right? But we can pass objects also as parameters or arguments as arguments to methods which take objects as parameters. Okay, like this. Okay, this is a method which takes two box objects as parameters. Which takes two box objects as parameters. So while calling, so here what we are doing, we are passing two objects. Okay. So while calling that method, we are passing this particular object and this particular object. What are they? This is our B. This is our cube. Okay, cube object and B object. Okay. So inside this method, we are trying to see whether both the objects, whatever the instance variables are same, right? Or whether all the instance variables are same or not for two objects, box A and box B. We are trying to see whether these instance variables are same. If the instance variables of both the objects are same, we will tell that okay, yeah, this particular these two objects are equal. That is true, and otherwise we will return false. So based on that one, we will print yeah, both the objects are equal or both the objects are not equal. Based on that one, okay. So the main intention here is to pass objects here, okay, and then take action based on the objects, state of the object. Okay, so intention is to see how we will pass objects to a particular method. Not only primitive types, we can pass objects also. Okay, complex data type objects also. So apart from this, can we pass objects as return types? Can we return objects as from a method? Okay, so there are two other things which needs to be remembered with respect to method argument passing. Okay, method argument passing. Okay, one is this is done how the method arguments, when you pass arguments to a method while calling the method. So what is happening? What happens? Two types of okay, how the arguments are passed to the method. There are two ways in which it happens in Java. One is call by value and call by reference. Okay, what is this value? Whenever we pass for primitive types, okay, for primitive types, whenever we pass arguments to a method which are primitive, the values of the primitive types are copied. Values of primitive types are copied. Okay, values of primitive types are copied, and inside method, if you try to do anything, or if you try to alter the values, whatever the values that you have passed, those things will not, altered value will not be reflected in your main where you are calling. Okay, for example, we have primitive types here. Okay, and then we are passing. We have what are we doing here? This is one method which takes primitive parameters, integer 1 and integer 2. Okay, that is what we are passing here. When we try to print these values before calling this method, it will be 10 and 20 only. Okay, and after calling this method, what are we doing here? We are manipulating I and j and returning sum. Okay, so what are we doing here? We are trying to manipulate I and j, which are taking the values from A and B. After calling this method, the values of A and B again are not changed. They remain 10 and 20 only. But sum based on this one, whatever the return value, right? We are capturing that return value here with integer and then printing it. So some will differ based on what we pass to INJ. Okay, but with this is how this is happening. Whatever the values that we pass with the A and B, they are copied to I and J. And if you try to change the values of I and J, they are not reflected in the values of A and B. That is why A and B remain same. Even after calling the method, A and B remain the same. Okay. We are not actually altering the values of A and B. We are altering the values of I and J here. Okay. So the values of I and J will not be reflected in A and B because the values of A and B are copied, not exactly A and B references. Okay, per se. This is your call by value. Okay, this is your call by value. So how this happens only for primitive types. This happens only for primitive types. Okay. So let us see how it happens for objects. Okay. So this is one object, and what are we doing here? This we are passing. So default object we are creating. Okay, if we are using default constructor, that is our box constructor. So all values will be -1. Okay. So then we are changing the dimensions of the box by calling this particular method. Okay. So we are changing the dimensions here, 100, 200, and 150. Okay. So when we come to this particular point, right? When we come to after calling this method, and when we try to print the state of object, the object state would have changed. Because objects are passed by references. So references are copied, actual references are copied. So whenever you make changes to any of the instance variables within a particular object, the change will be reflected in this particular object, this object. Okay. So that the result we can see here. So initially the box object is like this, and after assigning the values is here. So we are trying to print different values here, right? So after calling the method, the dimensions became like this. So height, width, and depth we have changed the values. That is reflecting even after calling the method. That means the object state itself has changed. We have because we have passed the reference of the object, that is address of the object, that is, and making the change using the reference itself. So with this, this is just an example to show how objects are copied. Okay, references are copied. So what are we doing? We are passing the reference of box object here. That reference will be copied in this particular box object. Okay. Then just to show, this box object, whatever the reference that is contained in this box object, is copied to y. Okay, and then we are changing the instance variable of y object. Okay, but that reflects in your box object as well as the reference that is passed while calling this particular object. Okay, so what exactly is happening? We have a box object, height, width, and depth. Okay, so three objects are pointing to this particular object. Okay, three reference variables are pointing to this one. One is our default box. Default box instance variable. Another one is our box. This is our box, and one more is our y. Okay, this is our y. Okay, all three instance variables are variables. Objects are pointing to this particular memory location, which has initially -1, -1, -1. Okay, so they're all pointing to this particular memory location or reference. Okay, or the object which has all these things. Okay, so whenever we pass an object to a method, the reference is copied. Okay, reference is copied. That is why all these things are pointing to the same memory location. Okay, all these things are pointing to the same memory location. So whenever we make changes to any of these objects, okay, whenever we make changes to any of these values, instance variables through any of these objects, that will be reflected in all the three objects. Okay, because we are accessing this memory location through the reference that is copied in this particular object. Okay, so that is why when we made changes to the state of default box through y, it reflected in y as well as box as well as in default box object, all the three objects. Okay, so yeah, Pawan, you have a question?
Yeah, hello sir. Sir, actually, is it I'm audible?
Yeah,
hello?
you are audible.
Yeah, okay. And when we take C++, we have pointers to create a reference, right? Okay, but in Java, like, do you have anything something like that which creates a reference so that the change in values completely?
Yeah. No, actually, what exactly happens in C++, right? You can deal with pointers. Okay, you can directly access those. You can directly access the address of memory, and then deal with whatever you want to do. Or you can manipulate addresses also based on the size of your bytes, and like how that actually handled in C++ itself. The same way you can manipulate addresses and then go ahead with whatever the things that you want to do, you can do it. Okay. But here in Java, there is no concept of pointers as such. Okay, so just we call it as reference. There also you can call it as reference in C++, but we cannot manipulate. Only we will get those references only through our new operator.
Okay.
Okay. So the new operator. Yeah. Okay, go ahead. Let me finish this part. Sure. Okay. So we have seen that new operator creates it allocates memory, right? It allocates memory and returns a reference to that particular object. Okay, that is when this new operator returns a reference, we will save those references in one of these variables. Okay, one of these variables, like whatever the class variable that you declare. Okay, so what is happening? Like box b is equal to new box, right? So this is a variable of type box. Okay, so when new operator returns a reference to the object that is created, that will be stored here. So this will have some reference. Okay, say for example A, B, C, some reference will be there. Some reference will be there, which we will, I mean, in C also you can see, I think, hex code, I think, right? If you try to print the address, you will see hex code. But here it will not be like that. In Java, that is a bit different, okay? But this actually represents the address of this particular allocated memory, okay? But you cannot, in Java, you cannot manipulate it. The only way you can get this address is through new operator. You cannot manipulate it. You cannot add numbers to it or whatever you do in C++, okay? Just by this one, we get the reference, but it operates in the same way, like how it is done in C++. When you are accessing that location through this address, and you are manipulating the instance variables. Here, these are instance variables, right? Setters and getters is instance variables. You're manipulating instance variables, but remember, you're not manipulating exactly manipulating the address itself.
Okay.
You're not manipulating the address, but you are with this reference, you are trying to access these instance variables. Okay. So with this reference, we are trying on this particular object. You are trying to modify the instance variables, which I mean, since all these objects, right, box and y and default object, all are referring to the same object. Variables, you can call them as variables to differentiate. So whenever you make changes to these instance variables, right, they get reflected in all the three objects.
Okay. Sir, I have
you can ask. Yeah.
Okay, let us say we have a class called box. Okay. Okay. So initially we give the values as all the 3 dimensions -1. Okay. Then I create a new box. I mean, create one more box using new operator. Okay. Then I have set the values of these 100, 200, 150.
Okay. So this is what you are trying to ask. Give me a second. I'll just explain it. I'll try to do the same thing here, and we will try to run the program. Okay. So what you are trying to do is create new box object. Okay. With some values.
Yeah, random values.
Okay. Some values I'm trying to do here.
Okay.
And then I will pass the same thing to okay. So we will not do this part. Okay, so what you wanted was this one. Let's do box b is equal to new box. This is what you wanted, right?
Yeah.
Let us comment this part. Okay. So for this values we will try to print. Okay. And then we will assign box to it. Okay. Yeah, this is a very good question. Comment these things also.
Sir, can we print both the values here just for comparison? Here,
after
b equal to box. Now, after b equal to box, if we can print both the values, we'll have a clear comparison here itself.
Okay. Like this, right?
Yeah, right. So we'll have.
Let us try to comment all these things. Something happened here.
That's not commented, I guess.
Okay.
Yeah.
Okay. So let us okay. So these are our results.
Okay. So what happens in case we change the values of B? Okay. So in that case, will both the values be affected, B and the box?
Let us try that one as well. Okay.
Okay.
So let us try. Okay.
B
So we
dot
have
set.
options, right? Yeah. Right. Then okay.
Okay. Okay. Both the values will be changed.
Okay. So we will do one more thing. Okay. So that is we will comment this part. Okay. This is what is getting called when we try to print those values. Okay. So okay. So this is how your object looks. I mean reference looks. Object
Okay.
references look in Java. Okay.
Okay.
Okay. So see here. Okay. Here also you can see those references, right?
Yes.
So do they look same? Do they look same?
Yeah.
Initially, this was the default object that was created, right?
Right.
That was created. But afterwards, all these things are same, right? That is our B and our box. Okay. But note that we have lost this particular reference. Okay. That means whatever the object that we created initially, right? Default object, that is here. That object reference is gone. I mean, we cannot access that values of that particular object now.
Okay. Usually, right.
So this is the object that we created, right? First. Okay. This is what is this one.
Okay.
Okay. So let me erase everything and make it clear. So this is the default object first created. So the reference of that default object is this one.
Okay.
Okay. And then we passed one object that we created. This
Box.
reference is this one. This is copied here. This reference.
Yeah.
Okay. Then what did we do? We assigned
box.
this box reference to this particular object. Right. So now this reference, say for example this one 332, right? We will write it as 332. Okay. Both B and box are pointing to the same thing.
Okay.
Same object. Same memory location. You can call it as same memory location. Okay. That is why when you try to print the object, both are like when you try to print this one and this one, the reference that is contained in both the objects, right? That is printed here.
Okay.
Right. But now we lost the control of this particular memory location because we cannot access after this is assigned. We cannot if we try to access anything from this reference, right? This reference we will not be able to access. We will not be able to access.
Okay.
Because now this object is pointing to the location 332, not 5C2.
Okay.
Okay, so when we try to access anything from B, we will be accessing from 332, not from 5C2.
Okay.
Okay, and also here, right, when we try to access B or try to change the values through B, we are changing the instance variables of 332, not 5C2. Okay, so that is why so B and box both are pointing to the same memory location, right? So we are accessing the instance variables state of that particular object. Okay, state of that particular object using this particular reference. So those values are changed. So that is why, since these two objects, B and box, right, pointing to the same thing, the values have changed for these two things. Okay, and one more important thing here is, well, let's try to do this also. Let us try to print the values of new box here. Okay. So this is the actual object. So whenever we run, the object reference changes. Okay, so we have run it again, right? So object reference changes, but you can see the reference.
It's the same.
Yeah, first, the different is this is the default box which we created inside change dimension 332, and this is F18, 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 and this is the object which was created here, the actual object. Okay, if you try to print that, if you try to print the same thing right here, after the this one, so let us try to print this one as well. Okay, this is the object that was created first. This is what we are passing to this particular method. That is our change box dimensions method, right? So compare the references 81C, 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 right? So let us try to print those values. Okay, let us try to print those values. Go to box. Uncomment these parts. Now we understood why the values are changing, right? So when we try to run this, so we are trying to print the values, right? Height is 12, 13, and 14. That is what we passed, right? That is what we passed. Yes, Kavita, correct. So now inside the change box dimensions, Kavita is telling 12, 13, 14. Correct, Kavita. So height default box object is created. Okay, and then we are changing it to 12, 13, 14 because the default object is this object. Whatever the object that we created, we are assigning it to default box object. Okay.
We are setting the box values to B, right?
Yes. So and then we are changing the values to 100, 150, and 200. The same thing is getting reflected here. So after that, after the method is, the change box dimension method is called, if you try to print the values outside of this method, okay, outside of this method, outside of this method, right? Outside of this method, we are trying to print the values here, right? So the values have changed. And one more important thing, right? So when we were discussing about methods, okay, when we were discussing about methods and scopes, right? When we were discussing about methods and scopes, we mentioned like whenever you define any variable, okay, within a method, that variable, the lifetime of variable, when we are discussing, right, lifetime of variable. So when you come out of this particular block of code, the life of a variable ends after this block. We are out of this block. That's why that variable will not be visible or accessible, right? So what is happening here is here. It's an interesting point to note. Okay. So what is this is a method, right? Box dimension is a method. Okay. So we have created this box object and assigning all these things, right? Assigning all these things. But if you go out of, this is our scope, method scope, whatever curly braces, closing curly braces, right? That is our method scope. So if you would have mentioned any other variable, normal primitive variable, right? Primitive variable, like say int I is equal to 10. Okay, unless until you return this value, this will not exist outside of this method. When you come out of this method and go to the main method, right, this will not exist because the lifetime of this particular primitive type starts with this curly brace or as soon as you call this method, okay, and then ends after you return from this particular method. Okay, this is for your primitive types. This is for your primitive types. But with reference to with respect to objects, right, that will not hold good. The lifetime of primitive primitive variable starts and ends with this scope, okay, one particular scope. But for objects, as long as references exist, any object reference exists, we are talking only about references, right, and accessing state of a particular object using this object reference, right? Object reference. As long as at least one object reference is pointing to that memory location, we can access those values. The life still exists. The life of the particular object still exists because this object reference, as long as this object reference is there, in the sense any object reference variable exists which is pointing to that memory location, it will be there only. Okay, we can access those values, right? Yeah, Pawan. Yeah.
Yeah, I mean, like, I have one more doubt, sir. Like,
Yeah.
okay, like, in the overloading also, we just keep changing the values, right?
1 minute, Pawan.
Okay.
Okay. Yeah. Overloading also. What was your question, Pawan?
Yeah, actually, my question is, even in the overloading, we keep changing the values, right? It's like initially we assign it as 0, then we change it to 100, 200. Just keep changing the values, right?
Which one? Here you are talking about these things?
Yeah, I mean, like, in general.
Okay. Yeah. So the same concept, whatever we discussed here, right? The same concept holds for method overloading, or for example, constructor overloading also. Say for example, I want, okay. So we will take this particular thing. Okay. We will do one more thing. So whatever you are doing here, right? Whatever you are asking, you will take one more method or constructor. Okay. So what are we doing here? Any object which invokes, right? With the, or which is what we are trying to do here is we are passing an object and copying the values of that object to the one which is created with this particular constructor. Okay, let me show that one. Okay, so what are we trying to do? This is what we try to ask, right, Pawan? Manipulation, right? So what we have done, we have created new object. Okay, we have created new object, and then I want another object. Box, another box is equal to new box of new box. Okay, now these are our actual box objects. That is our box object that was created, right? This one, new box. Okay, so these are the dimensions of your another box. Okay, okay, so you can see the results, right? Okay, and no, I think I did not get your question properly. I think, Pawan. So overloading. So what is your question? Can you come again, Pawan?
Yeah, actually, my question is, it's like what we are doing right now is overloading, or overloading means something else. That's all.
This one is not overloading. No, this is not overloading. Okay, so I got your question. So this is not overloading actually. So what we are trying to do, we are just passing the object. What I was explaining was this particular concept.
Change of values.
When you are passing or when a method takes objects, right? When a method takes objects, and when you are calling that method, you pass arguments, right? You pass arguments to that method. For example, this is your method definition, right? It takes box object, and you are calling that method here. You are calling that method here, right? Okay. So this is your argument. Yes, Kavita, correct. You can do that one. Yes, correct. So this is your uh, Yeah. So this is your argument, and when defining your method, right, that is your parameter. While passing argument to a method, you are calling the method here. You are passing the argument here. Okay. For objects or complex types or your class types or your class types, right? All these concepts, right, they're very, very important. Okay, they are all very, very important. These all concepts are very important because when you attend interviews, right, people will ask different questions indirectly, which is related to these particular concepts. Okay, mutability, immutability, all those things. Okay, so this is the argument. What are we passing with respect to these things, right? Primitive types, we just copy the values of whatever argument that is passed. Okay, but here what are we doing? We are copying the reference of object. We are copying the reference of object. Okay, a reference of an object is nothing but how we printed earlier. It looks like some a at the rate, all those things, right? ABC at the rate, all those things, right? That reference is copied here. Okay, so for objects, complex types or class types, the arguments are copied by reference. With primitive types, it is just the values. Okay, it is just the values. That is why inside method, right? Inside method, after passing this inside this method, whatever the values that we change, those are reflected after that method is also called. After that method is called in different objects, whichever which are the objects that are referring to that memory location, right? You can see the changes are reflected in all the objects that are referring to that particular object memory location. Okay, whatever the object that is pointing to that memory location, the values are reflected in those objects after the method is called. That's what we saw. So what I was explaining is how the arguments are copied by reference, not the method or constructor overloading. Okay. Did it answer your question, Pawan? Hello, Pawan? Not able to hear you, Pawan. Yeah, Kavita is telling this. You can use. Oh, okay. Yeah. Okay, Pawan. Yeah, Kavita is telling one particular. Okay, she's telling can we use like this? Okay, this has a different meaning. Okay, this of A, B. So all these things, this we will discuss in later sessions. Okay, later classes. Okay, so this has a separate meaning. So there are different ways of using this, right? This keyword with respect to instance variables, with respect to objects, with respect to constructors, and also you can use this with methods, right? Okay, so all these things we will discuss as and when we come to the particular topic. Okay. Okay, let us. If you have any questions, we will discuss those things. Otherwise, we will wind up this session. Okay. Anyone has any question? Yeah, we will discuss this one as we just mentioned, Kavita. We will discuss this of this of in upcoming sessions. Okay, later sessions. Anyone has any other questions or doubts? Okay, let us wind up this session. Okay. Yeah. Thanks everyone. Thanks for attending this session.